Let's quickly revise 9th standard ICSE, Physics Chapter 2, Motion in One Dimension. Now Section A is about some terms related to motion. First, let's understand the difference between scalar and vector quantities. Scalar quantities only have magnitude and no direction. For example, mass, 5 kg, it has no direction. Temperature, 2 Kelvin, no direction. Distance, 5 meters, no direction. But displacement, velocity, acceleration, weight, force, they have a direction. So such quantities are called vector quantities. We shall study the difference between them shortly. Now let's understand the meaning of the word motion. Rest and motion are relative terms because they depend on the surroundings. It is always compared to the background. Right now, I seem to be at rest because I am at rest with respect to my surroundings. But if a person from space is observing me, or rather this building, since the earth is rotating, the entire building, and hence I am also moving. So for him, I am not at rest. Motion in one dimension means along a straight line. Practically, all motion is in 3 dimensions, but for simplicity, we are going to study only one-dimensional motion and will solve numericals related to it in this chapter. Next, let's understand the difference between distance and displacement. If a person moves from Mumbai to Pune, and let's say the total distance covered is 400 kilometers, and the total time taken is 10 hours. Now the distance traveled is 400 kilometers, but the displacement is not 400 kilometers because the displacement is the shortest route between the starting and the ending point, which in this case, let's say is 200 kilometers. Another example is if you move 3 meters east and then 4 meters north, the total distance traveled is 7 meters, but the displacement is actually given by this hypotenuse, which will come out to be 5 meters northeast. So you see, displacement is different from distance. Displacement is a vector quantity where the direction matters. Displacement can be negative as well. For example, after traveling 3 meters east, if you travel 2 meters west, the total distance traveled is 5 meters, but the total displacement between the starting and the ending point is just 1 meters east. You see, 2 meters west can also be written as minus 2 meters east. So 3 minus 2 is 1. So the negative sign here simply means that the motion is in opposite direction. Distance cannot be negative, but displacement can be negative. And usually displacement is smaller than the total distance. Distance and displacement can be equal if the direction of motion is along a straight path. So if the distance traveled is 10 meters, the displacement is also 10 meters. One more surprising thing about displacement is that for a moving object, the distance can never be 0, but the displacement can be 0. What if the object comes back to the original position? The total distance will not be 0. We'll add the 2 distances covered. But the total displacement now is 0. So in a circular motion, when the object comes back to the original position, the distance traveled is 2 pi r, the circumference, but the total displacement is 0. So these are the differences between distance and displacement. Now let's understand the difference between speed and velocity. The formula for speed is distance upon time. Yes, the symbol for distance or displacement is capital S, and the symbol for speed and velocity is V. The SI unit of distance and displacement is the same, meter, and the SI unit of speed and velocity is the same, meter per second. Let's focus on this example now. If I calculate the speed, it is 400 kilometers upon 10 hour, that is 40 kilometer per hour. That is the speed of the car. Understand that this is the average speed. It doesn't mean that the driver drove at exactly 40 kilometers per hour in the entire journey. He must have paused, taken a break. Sometimes his speed might have increased to 100 kilometers per hour on the expressway. Sometimes it must have decreased to 10 kilometers per hour in a traffic jam. But the average speed is 40 kilometers per hour. Average speed is total distance upon total time. But what about the average velocity? Average velocity is total displacement upon total time. And what is the total displacement? 200 kilometers. So 200 upon 10 comes out to be 20 kilometers per hour. So you see the velocity is now different from speed, and velocity has a direction. Velocity can be negative, which would simply mean it is in the opposite direction. So instead of saying 20 kilometers per hour towards the east, I can call it minus 20 kilometers per hour in the west. This is useful while doing numericals. So we talked about average speed and average velocity. Let's talk about instantaneous speed and velocity. Instantaneous means at a particular moment. So if I were to just call up the driver at a particular moment and ask him, what is the speed right now? He would look at the speedometer and say it is 45 kilometers per hour. By the way, talking over the phone while driving is not good. After half an hour, again I call him and I ask him what is your speed at that instant, and he would say it's 85 kilometers per hour. So at different moments, the speed or velocity is different. That is called instantaneous speed or instantaneous velocity. Velocity will have a particular direction as well. And how is that calculated by the speedometer? Well, the speedometer simply calculates the distance traveled in a short unit of time at that moment. So the distance traveled in that one moment, say in 1 second, how much distance was traveled, that is used to calculate the instantaneous speed or velocity. So the instantaneous speed is different from the average speed. On average, the velocity is 20 kilometers per hour. But if I check after every half an hour, the velocity will be different. It won't exactly be 20 kilometers per hour every moment of the journey. Yes, the instantaneous speed can be equal to the average speed if an object is moving with uniform speed. Uniform speed means it is covering equal distances in equal intervals of time. So after 1 hour, it covered 40 kilometers. After second hour, it covered 80 kilometers. So it is covering equal distances in equal intervals of time. So the instantaneous speed will always be 40 kilometers per hour, and the average speed is also 40 kilometers per hour. The instantaneous velocity can be equal to the average velocity similarly, but for velocity the direction should not change. So what is uniform velocity? Uniform velocity means the speed is constant and even the direction should be constant. If the direction changes, then the velocity is not considered uniform. For example, if you have a circular motion like that of a fan, the blades of a fan, it is moving with a constant speed. It is covering equal distance in equal intervals of time. But is the velocity constant? Speed is constant, that is the magnitude is constant, 5 meters per second, let's say. But the direction of motion keeps changing. At every point, the direction is along the tangent to the circle at that point. And since the direction of motion keeps on changing, the velocity keeps on changing. So this is not uniform velocity, even though it is uniform speed. Next, we'll talk about acceleration. So whenever there is a change in velocity, we call such motion as accelerated motion. So here, the speed is constant, and yet this is an example of an accelerated motion. Whenever there is a change in direction, the velocity has changed, and hence there is acceleration. Now, velocity has a direction which is same as the direction of motion. Acceleration's direction is the direction in which the velocity has changed. So here, in the circular motion, acceleration's direction is actually towards the center of the earth, center of the circular motion. However, this is explained in detail in 10th standard syllabus. Now, acceleration's formula is v minus u upon t, that is final velocity minus initial velocity upon time. If there is no change in velocity, then there is no acceleration. For example, a raindrop. Initially, when it starts falling towards the earth, there is an acceleration due to gravity, but then the gravitational force is balanced by the frictional force of the air, due to which it starts falling down with a uniform velocity. That means uniform speed and constant direction, which is downwards. On the other hand, when you drive a car in a crowded place, that is an example of non-uniform or variable velocity, because the velocity keeps changing. Either your speed changes, or your direction changes, or both change. So that is variable velocity, which is also called acceleration. So let's calculate the acceleration in a particular example. Assume that initially a car was moving at 0 meters per second, which is, it is at rest, and after 10 seconds, its final velocity is 20 meters per second. Clearly, the velocity is increasing. So what is the acceleration here? If we calculate, it comes up to 20 minus 0 upon 10 meters per second, that is 10 meters per second, that is meters per second squared. So this is the SI unit of acceleration. I'm sorry, this will be 2. Now what does this mean? It means that every second the velocity is increasing by 2. So after 1 second it is 2 meters per second. After the second it is 4 meters per second. Then it becomes 6 meters per second. And after 10 seconds its velocity is finally 20 meters per second. So every second its velocity is increasing by 2 meters per second. This is the meaning of acceleration, the rate of change of velocity. How much is the velocity changing per unit time? Now here I am assuming that there is a uniform acceleration. That is, the change in velocity is equal in equal intervals of time. But that is not necessary. It is possible that this car initially increased its velocity to 4 meters per second, then it became 6.5 meters per second, then it became 9 meters per second, and so on. So this is non-uniform acceleration. And this calculation will just give us the average acceleration. Now, acceleration can be negative as well, which is called retardation or deceleration. Imagine there's a car moving at 20 meters per second, it applied brakes, and after 10 seconds it came to a stop, so its final velocity is 0 meters per second. So now what is its acceleration? As per the formula, it will be 0 minus 20 upon 10 seconds, which is minus 2 meters per second square. Negative acceleration simply means that the velocity is decreasing with time. Here the negative sign does not mean in the opposite direction. That was true only for displacement and velocity. But in acceleration, the negative sign means that it is moving ahead, but its velocity is decreasing. So what is the retardation here? 2 meters per second square. When you talk about retardation, no need to put the negative sign, because retardation by definition is negative acceleration. Now, let me give you an example of uniform acceleration, which is acceleration due to Earth's gravity. We know that any object falling towards the Earth from a great height will start accelerating. Initially it's 0 meters per second, then its velocity increases to 9.8 meters per second, then after 2 seconds it becomes 19.6 meters per second, then it becomes 29.4 meters per second, and so on. So what we observe here is, after intervals of 1 second each, the velocity is increasing by equal intervals, which is 9.8 meters per second. The velocity is increasing by equal quantity. Hence, we say that the acceleration due to gravity of Earth is 9.8 meter per second square, which depends on the gravitational force. Now, on the surface of the Earth, the gravitational force is maximum. On top of a mountain, the value of G is less because it's far away from the center of the Earth. So perhaps it will be 7.9. On the moon, gravity is very weak, so the acceleration due to gravity out there is only 1.67, means things fall very slowly out there. And you can jump to a greater height on the moon. You can try it if you want a proof of it. Also, if we go deep inside a moon, or any planet, or Earth for that matter, surprisingly, even though you're closer to the center of the planet, like Earth, the value of G again decreases. That's because the gravitational force acting on you is reduced, because you can think of it like a gravitational force is acting on you by the crust as well, pulling you outwards. So the net effect is that the value of G decreases as the altitude increases as well as the depth increases. So the value of G is maximum at the surface of Earth, and that too, it is maximum at the poles, because you see Earth is bulging at the equator. So at the equator, the value of G is a little less, say 9.78. And at the poles, you are slightly closer to the center of the Earth, so the value of G is maximum, it's around 9.83. And this acceleration due to gravity is true for all objects, irrespective of how heavy the object is. That means that if you throw an elephant and a feather from a height, both of them will reach the Earth's surface at the same time, because the value of G is same for all objects. Yes, practically the feather would fall down very slowly because of air resistance. But if there was vacuum, if there was no air resistance, then the elephant and the feather would reach the Earth at the same time. But do not try this at home. 9th Standard Physics, Chapter 2, Motion in One Dimension. It's not one direction, it's one dimension. First of all, some terms related to motion. Scalar and vector quantities. This is the definition of physical quantities. Scalar quantities are expressed only by their magnitude, whereas vector quantities are expressed by magnitude and direction both. Examples have to be learned, like mass, length, time. They don't have a direction.
distance, density, volume, speed, temperature, potential, work, energy, power. Surprisingly, work is also a scalar quantity. Pressure, quantity of heat, specific heat, charge, electric power, resistance, density, mechanical advantage, frequency, angle. So there are some terms like mechanical advantage, which you will study in 10th standard. But right now, you just remember that they are scalar quantities. They don't have a direction. Vector quantities, examples are displacement, velocity, acceleration, moment of force or torque, and so on. Dipole moment is something we'll study in college level. Notice that they are represented by a bar, an arrow on top. Now, scalar quantities can be added or subtracted by simple arithmetic methods. But vector quantities, they follow different algebra. For example, here in figure 2.4, a person moves from O to A and then to B. So the total distance traveled is 4 plus 3, 7 kilometers. But the displacement, it's a vector quantity, and the definition says that it is the shortest route between the initial position and the final position. So that is 5 kilometers, which could be found by Pythagoras theorem in this triangle because it's a right angle here. But what if it wasn't? What if it was an obtuse angle? Then we would have to use complex math like trigonometry, etc. to calculate the displacement. Another weird property of displacement is that it can be negative. So if I say the displacement is 5 kilometers east, that is the same as saying minus 5 kilometers west. So the negative sign for displacement or velocity represents opposite direction. But that's not true for other quantities like acceleration. In acceleration, the negative sign simply means that it is slowing down or there is a retardation. Next topic is rest and motion. Absolutely nothing is at rest in the universe. Since the Big Bang, everything has been moving. However, if something is at rest with respect to its surroundings, we can define it to be at rest. So that's a good reason. The definitions are here. One-dimensional motion is a motion in a straight line. It is also called rectilinear motion. Cancel this first paragraph. If you notice in figure 2.1, unequal distances are being covered in equal intervals of time, which means this is variable speed, not uniform speed. It's variable velocity as well. In fact, it's an accelerated motion. Whenever velocity changes, it's acceleration. The difference between distance and displacement has already been explained. Displacement is always less than the distance or equal to distance. They are equal only if you're traveling in a straight line. If you change the direction even once, then displacement will be less because displacement is the shortest path. So here we have a definition of distance and of displacement. The SI units are same, meter. Cancel this paragraph. Differentiate between them. Well, that's an important question. The first point is a definition. Secondly, this is scalar and this is vector. This depends on the actual path followed, but this does not. Distance is always positive. Displacement can be positive or negative, as I had explained earlier. Distance can never be less than displacement, although displacement can be less than distance. Both can be equal as well. Distance can never be zero for a moving object. Displacement can be zero for a moving object. For example, if this person traveled to A and then to B and came back to O, so the starting and end point is one and the same. So the total displacement is zero, although the total distance covered is 12 kilometers. This is especially true for circular motion. After each rotation, when it comes back to the original point, we say that the total displacement is zero. But what would be the total distance traveled? Well, that would be equal to the circumference, which is 2 pi r. So that's what is mentioned here. Next topic is speed and velocity. Speed is the rate of change of distance. So simply speaking, distance upon time. So its SI unit is meter per second. It's a scalar quantity. If you're covering equal distance in equal intervals of time, that's uniform speed. For example, a ball which is moving on a frictionless surface. But usually surfaces do have friction, so they will slow down. So that will not be uniform speed. Non-uniform or variable speed is what we see in our daily life. That is, for example, a ball moving on a rough surface or a car moving in a crowded street, because unequal distances will be covered in equal intervals of time. You can see that on the speedometer of your car or your vehicle. Instantaneous speed. So if the speed keeps changing, then at any moment, when you look at the speedometer of your bike or your vehicle, you see the speed at that point, 40 kilometers per hour. After 1 second, you see it to be 42 kilometers per hour. After a few seconds, you see that the speed has decreased to 33 kilometers per hour. So every instant, you are seeing something called instantaneous speed. The formula for that is distance traveled in a very short interval of time upon the time interval, which could be as small as the last 1 second or the last millisecond. The smaller the time interval, the more accurate an answer you would get. But we don't have numericals based on this formula. We have the simple numericals based on the usual formula. Average speed. Now imagine that you have covered a long distance with variable speed. For example, you went from Mumbai to Pune via car. Then obviously you will not be traveling with uniform speed throughout. So if you find the ratio of the total distance and the total time, that is average speed. Let's say the total distance between two cities is 300 kilometers, and it took totally 2 hours for the journey. So what was the average speed? It would be 300 upon 2, that is 150 kilometers per hour. That's the average speed. Doesn't mean that you were traveling at 150 at all the points on time. Sometimes you went above it, 180 kilometers per hour, sometimes below it. Sometimes you even took a stop and took some rest. But the average speed is calculated like that. When can the average speed and the instantaneous speed be equal at all times? Only when you are traveling at uniform speed. If from start to end you've been traveling at a fixed speed, then the average speed will be same as instantaneous speed at every point. Now velocity. Well, that's the distance traveled per second by a body in a specified direction. It's a vector quantity, so direction matters. I like this definition better. Rate of change of displacement. So that's displacement upon time. That's the formula of velocity. The SI unit is same, meters per second. Now, when we say uniform velocity, it should cover equal displacement in equal intervals of time. That means equal distance in a particular direction in equal intervals of time. Just because the speed is constant or uniform doesn't mean that the velocity will be. Imagine in this circular motion, equal distance is being covered in equal intervals of time, let's say 10 meters per second. And yet, it is not uniform velocity because the direction of motion keeps on changing. At every point, the direction of motion is along the tangent. So the direction keeps on changing. It's not traveling in a straight path. And since velocity is a vector quantity, if the direction keeps on changing, then the velocity keeps on changing. You see, here I would say the velocity is 10 meters per second north. But here I would say the velocity is 10 meters per second west. So though the magnitude is same, 10 meters per second, the direction is different. That means velocity is different. And whenever velocity is different, we call it an accelerated motion. So all circular motion is accelerated motion. In fact, any motion which is not in a straight line has to be an accelerated motion, because acceleration is the rate of change of velocity. And if direction changes, velocity changes. Even if you take a turn while driving a car, it can be called as accelerated motion. But example of uniform velocity will be a raindrop falling from the clouds towards the Earth's surface. But we are imagining that initially there was some acceleration due to gravity, but later on, because of the friction with the air, it starts falling down with a uniform velocity in a straight line. Non-uniform velocity, as I said, it means either unequal distances are covered in equal intervals of time, or equal distances are covered in equal intervals of time, but the direction keeps on changing. So either way, it is a variable velocity, and that is an accelerated motion. Example of a freely falling body. Freely falling means without any air resistance, because it will keep on accelerating. Its velocity will keep on increasing towards the Earth. What is instantaneous velocity? Just like instantaneous speed, the velocity at a particular instant, which is measured with the formula, the displacement upon time interval, and the time interval should be taken as a very, very small time interval. Average velocity is the total displacement upon total time. Surprisingly, it can be zero, because if something comes back to the original position, the displacement is zero. And if displacement is zero, average velocity is also zero. So if you go from Mumbai to Pune and come back, and somebody asks you what is the average velocity with which you rode the car, answer is zero. That's because it's a vector quantity. Now the distinction between speed and velocity we'll learn from the table, so you can cancel all this. First point is a definition, second it's scalar and vector. Speed is always positive, velocity can be negative as well, because negative sign means it is in the opposite direction. And here average speed can never be zero, but here it can be zero. Example number 2, mark it as a GR, that why is a body moving in a circular path a variable velocity? As I said, because the direction keeps on changing. Just add something here and hence accelerating. Next, cancel this paragraph. Now, acceleration is defined as a rate of change of velocity, that is, increase or decrease in velocity per second. If it is decrease, then we have a special name for this negative acceleration. It's called retardation or deceleration. The unit of acceleration is meters per second squared. CGS unit is centimeters per second squared. And the formula is A is equal to V minus U upon T, where it's final velocity, initial velocity, and time. If I cross multiply it, we get another kinematic equation called V is equal to U plus AT, where A is acceleration and T is time. Let's look at some examples. Example number 1. So initially you were at rest. Rest means U is 0. Final velocity is 20 meters per second. And you increased your speed in 10 seconds. So if you substitute the values in the formula, you get the answer as 2 meters per second squared. That's your acceleration. On the other hand, what if you were already moving at 25 meters per second and you applied the brakes and you were brought to rest? That is your final velocity is 0. Then, after substitution, we get a negative answer. Here, negative sign does not mean opposite direction. It is still moving forward, but since brakes are applied, it is slowing down and then it comes to a stop. This is called retardation. So, if acceleration is minus 5 meters per second squared, and if in the question they've asked for retardation, we will say retardation is 5 meters per second squared. Then you don't put the negative sign because retardation by definition is negative. So one way in which acceleration is different from velocity is in velocity the negative sign tells us about the direction of motion, whereas in acceleration we cannot determine the direction of motion by just looking at the answer. We don't know if this is north, the motion is north, south, east or west. The negative sign does not tell us that it is in opposite direction. That's the difference. Uniform acceleration is when the velocity increases with equal amount in equal intervals of time. For example, when object is thrown from a building, initially it's 0 meters per second, then it is 10 meters per second squared, then it's 20 meters per second, 30 meters per second. The velocity keeps on increasing and the increase is also consistent. The velocity is increasing by 10 meters per second every second. So we can say the acceleration is 10 meters per second squared. The actual value is 9.8, which may be rounded off to 10 depending on what is the data given in the numericals. But notice that this value holds true only in free fall, that is no air resistance. If there is air resistance, there will be no acceleration due to gravity. It will just fall down with a uniform speed after some time. Variable acceleration obviously means that the velocity is changing, but it's changing unequally. Sometimes it's accelerating, decelerating with unequal magnitudes. For example, when you're driving a car on a highway or on any road, that's the best example of variable acceleration. But acceleration due to gravity is always towards the earth because of the earth's gravitational attraction. And on earth, the value of that g is 9.8. So if something is falling down, it's positive. If you throw something up, then there is deceleration. So that is negative 9.8 meters per second squared. Cancel all of this. Even on earth, the value of g is not constant. At the poles, it is maximum, say 9.82, because it is nearer to the center of the earth. And at the equator, it is slightly less. It's 9.78 meters per second squared. But the average we take is 9.8. Also, as the altitude increases, like on top of a mountain, gravity is weak, so the value of g decreases. In fact, as you go into outer space, gravity becomes weaker and weaker. Value of g becomes almost 0 in space, so you start floating. On the moon, value of g is very low. It's 1/6 of that of Earth. So your weight is also less. Yeah, weight depends on the value of g. Weight depends on the force of gravity. Mass doesn't change no matter where you go. One surprising thing is that as the depth increases, if you go inside the earth, then too the value of g will decrease, because now only this much part of the earth will influence you gravitationally towards the center of the earth. And a very interesting concept is, if you throw two objects having different masses towards the earth from the same height, you will notice that in vacuum, that is in free fall, both of them will reach the earth at the same time. Even a feather and an iron ball will reach the earth at the same time if air resistance did not exist then. This has been experimentally proven, because the value of g does not depend on the mass of the object. The value of g is independent of how heavy the object is. Everything falls at the same rate towards the earth.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.